This lesson covers section 9.2, ellipses. Our objectives for this section are to be able to write equations of ellipses in standard form, to use properties of ellipses to model and solve real-life problems, and to find eccentricities of ellipses. So the definition of an ellipse, which I would like you to memorize, along with the definition of circle and definition of parabola from the last section. An ellipse is the set of all points xy in a plane, the sum of whose distance from two distinct points, foci, is constant. So if you look at this picture here, we have an ellipse. Okay? There are two foci in the middle, and if we take this D1 and D2 and add it together, it will be the same no matter where we go around the circle. If you look back at the main page on PowerSchool Learning for section 9.2, there are two videos showing how you can draw an ellipse using two fixed points and a piece of string. And that's a really good demonstration to watch to show how, if you were to take a string and work its way around, the length of the string never changes, but based on where these two foci are located, the distance from those always stays the same. So if you're closer to the middle, it's going to be out here further, but when you get toward the end, then it'll be close to this focus point, but really far from this focus point. So anyway, that's a good video to watch to give you a picture of how all this works. There are some parts of an ellipse that are important to know. The first part are the vertices. So the vertices would be here and here, and the vertices are the endpoints along the major axis. Okay, the major axis is the longer of the two axes, and at the end of it, there are the two vertices. The major axis goes through the center of the ellipse, and the vertex on each side is equidistant from the center. Then there is a minor axis. The minor axis is perpendicular to the major axis, and at the end of that are two co-vertices. Now, your textbook doesn't talk about co-vertices, but they are important to be able to find them so we can graph our ellipses. So anytime you're doing a problem and it asks you to find the vertices, the center, the foci, also get in the habit of finding the co-vertices, because I will require you to find co-vertices on any tests or quizzes. So these are the important pieces of an ellipse that you need to know. And down here I explain in writing what all those points are. Okay, next, standard form of an ellipse. So if you have an ellipse with center at HK and major and minor axes of lengths 2a and 2b respectively, where b is less than a, but both of which are greater than 0. So in this is really important, okay? So with an ellipse, a is always bigger than b. So the form doesn't change. It's always x minus h squared plus y minus k squared in the numerators. And you'll see no matter whether the major axis is horizontal or vertical, that's the case. And it always equals 1. Then, if it's horizontal, that's because the major axis is linked with the x direction. So a is bigger than b and will be underneath the x. If the major axis is vertical, then a, the bigger value, is now underneath the y term, which is what makes it vertical. So here we have two diagrams showing that. So a squared is the bigger distance here, so it means it's a horizontal major axis. A squared is now underneath y, which means it's vertical, so it's a vertical major axis. Because remember, a squared is always bigger than b squared. So example 1, find the standard form of the equation of the ellipse having foci at -2, 2 and 4, 2 and a major axis of length 10. So to make our life easier, we want to sketch a picture. Now, I'm looking at this picture that I sketched in a previous year, and I'm thinking it's not correct, because if we have a foci at -2, 2 and another one at 4, 2, that means that the ellipse opens around those two focal points. So if they were vertices, that's where they would be, but they're not, they're foci. So they're actually inside the ellipse, not on the endpoints of the major axis. Now the major axis does go through those two foci, so that's going to help us. Now, right in the middle of those 2 points is the center. So we need to find the average. So if you notice, it's a horizontal major axis, and the equation of that horizontal line is y equals 2, so this center is going to have a y coordinate of 2. Now to find the x-coordinate, we do -2 plus 4, and then we divide that by 2. So -2 plus 4 would give us x equals 2 over 2, or x equals 1. So that coordinate is 1. Now from here, it has a major axis of length 10. So that means from the center, we go 10 in total. So I'm going to clean this up a little bit. So if I start at the center, and I go 5 in each direction, that will give me a total length of 10. So if I go 5 to the right, I end up out here at 6,2. If I go 5 to the left, I end up out here at -4,2. So I jotted down those two values. Now, from here, I filled in x minus 1 squared, y minus 2 squared, because that gives me the center point. Now from there, if the major axis is a length of 10, that means that from the center in each direction is going to be 5. And since this is in the horizontal direction, 5 squared is 25, so we put that under the x-coordinate. Now, to find the value that goes here where the 16 is, what we have to do is we have to use this equation here. C squared equals a squared minus b squared. C represents the distance from the center to either one of the foci. Okay? So from the center to the foci is 3 units, so we put 3 squared there. A squared is the bigger one, so that's 25, minus b squared. So when we do the math, we have 9 minus 25 would be -16. So -16 is -b squared, so that means b squared is 16. And remember, the value that goes here is b squared, so we don't have to do anything. We don't have to take the square root and then square it again. We can just use the 16. For our next example, we have to sketch the ellipse given by 16x squared plus 4y squared equals 16. Now, you'll notice this does not equal 1. Okay, on the first page of the notes, it said in order to have an ellipse, it has to equal 1. So to make this equal 1, what we do is we divide everything by 16. X squared divided by 1 plus y squared divided by 4 equals 1. Because there's nothing being added to the x and the y terms, it means the center is at 0, 0. Now, the square root of 1 is 1, the square root of 4 is 2. So that means in the x direction, I'm going to start at the center 0, 0 and go 1 in each direction. Since y is 4 and the square root of 4 is 2, that means in the y direction we go up and down 2 units, connect them, and that's how we get our ellipse. Okay? So, and I believe all we had to do was graph it. Yep, sketch the graph, so that's all we need to do. For example 3, we're asked to find the center, vertices, covertices, and foci of the ellipse given by 16x squared plus 25y squared minus 32x minus 50y plus 16 equals 0. So this is not in standard form, even close to it. The last one we had to divide to put it in standard form. This time we actually have to complete the square. So to get started to complete the square, the first thing we want to do is we want to group the x's and we want to group the y's, and we want to move the constant to the other side of the equation. So if we look at what I've done here, I have 16x squared minus 32x, and then I left a space so I can complete the square. Then I have plus 25y squared minus 50y, another space to complete the square, equals -16 from moving the 16 to the other side. Before I go about completing the square, I have to factor out the leading coefficient. So for the x's, I factor out a 16. So I'm left with 16x squared minus 2x, and I don't have the 1 yet. I'm going to put that in just a minute. And then over here, I would factor out the 25, which leaves me y squared minus 2y, and then I'm going to leave a spot here. So when I complete the square, I'll take half of -2, which is -1, square it and add it so I get plus 1. But to balance the equation, because there's a 16 here, it would be 16 times 1, so on the other side we add 16 to keep it balanced. Then for the y's, half of -2 is -1, square it, we get 1, 25 times 1 is 25, so that's what we add to the other side. Now we factor, so it's 16 times the quantity x minus 1 squared, and it's x minus 1 because this is a perfect square trinomial, so half of the middle term becomes our constant term in our binomial. plus 25 times y minus 1 squared equals 25. So from here, I can now combine everything over here, and that's where the 25 came from. In order to finish putting it in standard form, I have to divide everything by 25. When that happens, this 16 drops to the bottom, because if you think about it, if I were to divide this out, I would multiply by the reciprocal. So the reciprocal of 25/16 would be 16/25, which would give me back what I started with here. For the y term, 25 divided by 25 is 1, so that's why I don't have anything written there. And then on the other side I have equals 1, so I'm ready to go. Now, looking at my equation, I see that the center is 1, 1 because I have x minus 1 and y minus 1, so that gives me my center. Now, to find the vertices, we have to do a little bit of math, and it's also a little bit easier if I can sketch a picture to help me out. So, in order to figure this out, what I want to do is I want to take this a value because 25/16 is bigger than 1. So the square root of 25/16 would be 5/4. So in the x direction from the center, I'm going to add and subtract 5/4. So 1 plus 5/4 is 9/4. 1 minus 5/4 is negative 1/4. And then the y coordinate doesn't change. For the covertices, the b value is 1. So from the y coordinate, I'm going to add and subtract 1. So I get 1, 0, and 2, 1. Then, to find the foci, we do c squared equals a squared minus b squared. And when we add and subtract that value to the 1, so that is 3/4 when we do that. So that 3/4 gets added and subtracted to the x coordinate. So 1 minus 3/4 is 1/4, comma 1. And then 1 plus 3/4 is 7/4, and that's where that point comes from. So remember, the formula that we would use there is c squared equals a squared minus b squared. So c squared equals 25/16 minus 1. So that would give us c squared equals 9/16. The square root of 9/16 is 3/4, and then we add and subtract that to the x coordinate. Example 4 is find the center, vertices, and foci of the ellipse given by 2x squared plus 4y squared minus 4x plus 8y minus 2 equals 0. Please pause the video, try the problem, and restart the video to see if you got the right answer. So for this problem, we once again have to complete this square. To set up, we want to put 2x squared minus 4x, leave a spot, and then we're going to put the y's, plus 4y squared plus 8y, leave a gap, equals negative, oh, it's already a negative 2. Didn't see the negative sign, so equals positive 2. So before we can finish completing the square, we have to factor x squared minus 2x plus 4 times y squared plus 2y equals 2. So now I can take half of 2 is 1, 1 squared, I'm going to add 1, so to the other side I actually add 2. Same thing here, half of 2 is 1, I add 1, but I really add 4. So now I have 2 times x minus 1 squared plus 4 times y plus 1 squared equals 8. Now I have to divide everything by 8, so I get x minus 1 squared over 4 plus y plus 1 squared over 2 equals 1. So now it's in standard form, so now you can see the center is 1, negative 1. 4 is larger than 2, so this is once again horizontal. So from the center, we're going to add and subtract 2 to the x coordinate. So when I add 2, I get 3. When I subtract 2, I get negative 1, and the y coordinate doesn't change. For the covertices, okay, I have 2. Well, the square root of 2 is square root of 2. So from the y coordinate, I have to subtract and add root 2. So the 1 stays for the x, and I get negative 1 minus root 2 and negative 1 plus root 2. Now to find the foci, it's c squared equals a squared minus b squared. So c squared equals 4 minus 2. C squared is 2. So c is plus or minus root 2. So that means I have to add and subtract root 2 from the x's this time. So I get 1 minus root 2, and the negative 1 for the y from the center doesn't change, and 1 plus root 2 and the negative 1 from the y coordinate of the center does not change. Next, we're going to talk about eccentricity. Eccentricity is used to detect elliptical orbits of the planets. So the eccentricity E of an ellipse is given by the ratio E is c over a, where c is the distance from the foci to the center and a is the distance from the vertices to the center. For an ellipse that's nearly circular, the foci are close to the center, so the ratio c over a is small. For an elongated ellipse, the foci are close to the vertices and the ratio c over a is close to 1. So here are two examples. This one is almost a circle, so if we were to do c over a, because c is little and a is big, it's going to be a little number. Over here, c over a, because they're closer together, it's more elongated. So, example 5. Look at this, all kinds of fun stuff. Okay, so the first artificial satellite to orbit the Earth was Sputnik 1, launched by the Soviet Union in 1957. Its orbit was elliptical, with the center of the Earth at one focus. The major and minor axes of the orbit had lengths of 13,906 kilometers and 13,887 kilometers respectively. Find the greatest and smallest distances, the apogee and perigee, from the Earth's center to the satellite. Use these to find the greatest and smallest distances of the satellite from the Earth's surface in this orbit. Earth has a radius of 6,378 kilometers. Okay, so the first thing we have to do is we have to figure out the distance from the center to the vertices and the center to the covertices. So we can see here that it says that the major and minor axes were 13,906. So we're going to divide that by 2 to get our A value. Then B, the minor axis, was 13,887. We're also going to divide that by 2. When we do that division, we get A is 6,953, B is 6,943.5. And the reason we need that is because we need to find c squared equals a squared minus b squared, because that's going to give us the distance from the center to the focus, which is the distance from Earth. So we kind of need that. Okay, so using c squared equals a squared minus b squared, we solved and found that c was 363. So from there, we set up two equations, a minus c and a plus c. Now the reason for that is if right here is our Earth focus, okay, then we're going to go to the center. So to get from the focus of the Earth all the way to the other side, it's going to be the c, because Earth is the focus, so it's the distance from the center to the focus, plus a to get from the center all the way to the other side. Then from there, we are going to do the same thing, only opposite. We're going to do a minus c, because it's this whole side minus this little bit here will tell us how far that is. So when we subtract, we get 6,590 kilometers, and then when we add them, we get 7,316 kilometers. So the greatest distance was the apogee, so I used the technical term, and the shortest distance was the perigee, so I used the technical term there. So now to find the greatest and smallest distances from the Earth's surface, what we have to do is we have to subtract the radius of the Earth from the furthest and closest it was over here, the apogee and perigee. So we have to subtract that, and that will give us to the surface, because this was from the center of the Earth. So if we subtract the radius of the Earth, it'll give us the distances from the center. And that's how those numbers were calculated. Here is another example for you to try and look over. Okay? If you have questions on this example after trying it and looking it over, please see me and I will help you with it.